We can start to chapter 2 today. Chapter 2 is about the architecture of the microprocessors and central processing unit. To understand the hardware, first of all, we have to know this. What is the architecture of the microprocessor? We have to know this. Why? A good programmer can interpret and correct the errors belongs to any program if he knows the architecture and properties of the processor he programs. Here we have a general architecture of a CPU. What we have, let's examine it first. This rectangle represents the microprocessor, okay? And the outside of it, external world. Of course, external world for the microprocessor, but for us, physical world, okay? Our world. Yes, here we have some units, as you see. Let's start from interrupt control unit. Here we have 5 input from the external world, as you see, and interrupt control send or receive some signals from this bus. This bus 8-bit internal data bus. What's more, we have in here we have serial input-output control, and we have a signal from external world to the microcontroller, and one more from microprocessor to physical or external world. What else we have? Here we have 3 signal. 2 of them goes to the microprocessor X1 and X2, and one of them clock out from microprocessor to physical world. This unit is timing and control unit, and with these 2 input we have a clock generating unit. This unit also have 4 input or output. One of them is input to the microprocessor, is ready input, and the other of them can be evaluated as output, read, write, and AL. We will see in detail. Yes, here we have an address bus A8 to A15. It means the high byte of the information. In here we can see another address or data bus AD0 or AD7. If it is data, we can say D0 to D7. We have 8-bit data, but it can also be A0 to A7. It means this is address value and the first 8-bit information of the address. Yes, in here we have MAR unit, MAR memory address register, and also here MAR unit. We have a connection between this unit with the data bus, because as you see here, this information can be 8-bit data. Okay, so we have to connect it to the data bus. Another road here, if you follow it, we will see PC. PC is program counter. We will see it, stack pointer, and some the other registers. So these units are registers and connect with the data bus. Here, if we get an information. First of all, we evaluate it in the instruction register here, and then here we have another unit, instruction decoder. We'll talk about inshallah today. Yes, another unit here we have an accumulator A and temporary registers connected to the ALU. ALU is arithmetic logic unit. ALU is very important for the microprocessor arithmetic logic unit. And we have some flags which is affected by the ALU. We can understand it. And ALU can send some information to the 8-bit internal bus. Okay, this is the general architecture of a microprocessor, and we will see in detail today each of them or important of them. Yes, what is the command line? Let's start it. The command line defines the parallel connection. What kind of parallel connection? These connections carry the data for the same purpose. It's important. Same purpose. The number of the connection specify the number of bit that command line. It means we talked about yesterday 4-bit or 8-bit. It means we can send any information within the unit time at the same time, or we can say how many bits we can send. 4-bit, 8-bit. This is the about it here. It can be transmitted how many bits at the same time as another expression, as you see. We have another diagram here. Before this, we have to know this. There are 3 common lines. One of them is address bus, data bus, and the last one, control bus, which the logic control signals are transmitted. So, the common lines consisted of address bus, data bus, and control bus. This is the CPU, Central Processing Unit, or microprocessor. We have a control bus to transmit the information from the CPU to memory or vice versa, as you see. We have data bus to transmit the data and address bus. Another unit is the input or output units. These are evaluated as peripheral units, okay? External peripheral units. So to communicate with the CPU, we need 3 common bus: data bus, address bus, or control bus. But if you examine the address bus only transmitted from the CPU to memory or input-output units, not vice versa. But the other of them, control bus, for example, or data bus, transmitted with each other. Data bus, it is used to provide data communication between the processor, memory, and peripheral units. Okay, only we talked about the data. Address bus, it is used to send memory addresses to the ROM and RAM memories. These memory addresses provide access to the processor's program commands and data storage areas. As you see here, this is the data storage areas. We can send an address value to here. Yes, control bus, it is used to transmit signals generated by the control unit to the peripherals, and used to transmit the signals came from the related peripherals to the control unit. Let's see in detail now. CPU units and specifications. The first one is register and counter. These are consisted of flip-flops, as you see in the logic circuit lecture. These are binary cells, actually. Small pieces of information storage unit we can understand easily as like that. And the basic structure of them consisted of D and JK flip-flops. Yes, the basic structure of the counter is consisted of JK flip-flop. Yes, accumulator, it is the main memory of the CPU. It is especially defined the register that stores any arithmetic or logic operation result made with the ALU. This is so important information area for us. It has the same bit length as data bus. 8-bit microprocessor means that the microcontroller has 8-bit data bus and accumulator characteristic. Yes, data bus, it may be 4, 8, 16, 32, 64-bit. Okay. In microprocessor, generally 8-bit of data are received or sent. How can we store the information? If we have 8-bit information, we can store this information bit by bit, or we can represent it in the hexadecimal number system. We often use the hexadecimal number system. Okay, for example, if we have this kind of number starting from the low nibble, what is the value of it in the decimal number system? 6. And the other 4-bit in the decimal number system, 10. So we can say A in the hexadecimal number system. So this number is stored in the area as A6. ALU. ALU is arithmetic logic unit. ALU is arithmetic logic unit. Mathematical addition, subtraction, and etc. and or logical operations are performed in the ALU. Okay. We cannot reach directly to this area. It can only be processed by the commands. The ALU can be thought of as the brain of the microprocessor. Okay. It is brain of the microprocessor. We can use this similarity between human and microprocessor. Yes, buffer register, it is the unit of information stored before entering ALU. So we can easily evaluate that the buffer register is temporary register. Okay. It has the same bit length as the microprocessor. Yes, another important is clock. It generates the clock pulse, which is used as timing pulse by the control unit. How can we do it? The crystal frequency connected to the input X1 and X2 of the control unit determines the frequency of the clock pulses to be generated. Yes, here we have an X1 and X2 input for the microprocessor. We have to use here a crystal which determines the frequency of the clock pulses. Okay, as you see here, it is done in the control unit, and these clock pulses, generated clock pulses, can be sent to the external world with this output. What is the X1 and X2? Maybe we can see again on the architecture. Here, maybe I should use another color. Here, X1 and X2. clock generating timing and control unit. In here we have another expression. The clock pulse is thought of as heartbeats. Okay, heartbeats of the microprocessor, because processor doesn't work without the clock pulse. Therefore, it is very important. What is the brain for the microprocessor? ALU. And now we learned another expression. The clock pulse can be evaluated as heartbeats of the microprocessor. Yes, let's continue. Control unit. The control unit generates the signal necessary for the CPU to communicate with the external environment and controls the relevant units. The control unit can be thought of as the heart of the microprocessor. Heart. Okay? Why can we evaluate it as heart? As you see here, clock pulses is generated in the control unit. Okay? So we can easily say this control unit can be evaluated as heart. As you know, heartbeats to keep the organs alive, as the same way signals got from the control unit allow the units in the microprocessor. Maybe we can give another example. Please remember the flip-flops. How does it works? Yes, of course, clock pulse. If we don't have clock pulse, flip-flop keeps the last value of it. Okay? We said before, register or counters are consisted of flip-flops. We can say for the microprocessor doesn't work without the clock pulses. Okay? What is the duty for the control unit? It regulates the control errors for MUX and ALU. It produces read-write pulses for registers, memories, and input-output devices. It increases or decreases the program counter. This unit controls all operation and cannot be intervened. Okay? Yes. Instruction register, it holds the code that CPU will execute in binary code. So if we write any code, this code holds in here and CPU will execute in this binary code. Yes, instruction decoder, it identifies the information held in the instruction register so that the control unit can generate the correct timing and control pulses. If you write any command, first of all this command goes to the instruction register and then goes to the instruction decoder. That code first of all is decoded and then control unit generates the control signal to do this operation. Okay, the main logic of this. MAR is the memory address register. If a memory read or write operation is to be performed where the address of the desired region is held, so the address value is kept in it. Data address, data input output, memory address, read and write signal. The signals are generated by the control unit. As you see here, read and write signals are generated by the control unit. It's been heard. Address information is retrieved from the MAR, memory address register. It takes the knowledge of both the data and address buses. Okay, let's remember on the architecture again. Yes, here as you see, MAR we have. Until now, what we have, maybe we can check it. we see instruction register holds the command and then send to this command instruction decoder, and this information is decoded and the control unit generates the related clock pulse or control signal to do this operation. In here we have a MAR and MAR. It uses as address bus or data bus. We see it. And control unit, it is heard. We know it. And clock pulse, it is heartbeats. ALO is the brain. All arithmetic and logic operations done in it. Accumulator, it is the main register for the microprocessor. And that's it until now, right? Read and write signal, clock out, and crystal input. That's all. Let's continue. MUX. MUX is multiplexer. You have already know it in the logic circuits lecture. The MUX is an electronic switching element that selects the path for the transfer of information between register, address bus and data bus. It is checked by the control unit. Okay, again, as you see, control unit do this operation for the MUX. What about PC? PC is program counter. It is usually 16-bit. Please be careful. We use 8-bit microprocessor, but program counter is 16-bit. Okay, it keeps the address of the next command in the program. So the command to run will come from here. Okay, address changes are made on the PC. The line may be skipped. The address indicated by the PC can be incremented automatically after the last command is used or replaced with a new 16-bit command address loaded into program counter. So how it is possible? We have 8-bit microprocessor, but we said now program counter is 16-bit. How can be possible? So for the program counter, we can use 2 memory cell as like that. Okay, 8-bit and 8-bit. This is the low byte and this is the high byte. As you see here, the low byte called as program counter low, PC low, and the high byte of it called as program counter high. Okay, PC high. If you have 8-bit microprocessor, you cannot do 16-bit operation at the same time. Okay, we have to use 2 memory cell at least for the 16-bit. For the program counter, we will do this operation. For example, the data A6 and C1 is moved as A6 value to the PC high, program counter high, and then C1 is transmitted to the program counter low respectively. Okay, so we can say the first information transmitted to the PC, the high byte of it. Okay, high byte is moved to the program counter high, and then low byte is moved to the program counter low. Working register. These registers can perform various functions. Some are used as various memories and some as special function registers. The numbers of them can be too many, around 50-54, and they can be 8-bit or 2 times 8-bit. For example, if we want to add a timer, we can do it with working register.